Alright guys, this video is going to be very useful for anyone looking to replace their OEM rotor with an aftermarket one. It'll also cover the major issue with aftermarket rotors. So if you weren't aware, when you rotate your rotor around like this and you align it with your crown tube, you should see two dots align. So there's one dot right here on this little gear that engages with the winding rotor. And then there's another dot right here, and that's your post for your balance bridge. And when you rotate the rotor around, no matter which direction that you rotate it, as long as you realign it with the crown tube, you should see that those dots realign. And that lets you know that you're getting the maximum winding efficiency out of your rotor. And with aftermarket rotors, they no longer stay aligned. In fact, that little dot on that gear that engages with the winding rotor will spin a full 360 degrees, and that drastically reduces the winding efficiency. So I'll just go over how I removed the rotor. So you're going to need a screwdriver that fits the rotor. This is a cheap one from Walmart. These normally come in like a home toolkit, or sometimes they come in a set with both flathead and Phillips. So I selected the widest one because we're going to need a pretty broad tip, but they're too thick to fit inside the rotor. So I ground this one down with my Dremel, and that gives us a nice broad tip, but it also makes it thin enough to slot nicely into the rotor. So we can go ahead and use this. They do sell special screwdrivers for this, but they're expensive, and the cheapest way to do it is just make one yourself. So we'll go ahead and make sure our rotors align with our crown tube. And I do like to keep one finger on the rotor so it doesn't spin around on us. So we'll go ahead and unthread that from the movement. Once we have it unthreaded here, we can go ahead and grab it with a pair of tweezers. So we'll go ahead and grab that and set that aside. And for now, I'm going to go ahead and cover the movement with a dust cover while I go ahead and grab our aftermarket rotor from the Mokies. Going to go ahead and open this up real quick. And once we have it open, we can go ahead and remove our dust cover. And then we're going to go ahead and re-grab our tweezers and set that onto the movement. And again, we want to keep it aligned with our crown tube. And I like to use one finger again to hold the rotor still and stop it from moving on us. That way everything stays lined up. So we're going to go ahead and thread this in. You should also wear finger cots when you're touching the rotor or any parts of the movement. So go ahead and get that threaded in and then snug it down. You don't need to torque this too tight. You just want to snug it and then give it a nice check. Make sure it's tight and it's good to go. So at this point, I did think that the aftermarket rotors would keep those dots aligned and keep your winding efficiency. So here I'm just double checking to make sure those dots align. And again, when I first installed this, I thought that they worked the same way as an OEM rotor did. So at this point, I'm thinking, job well done. Our dots stay aligned, and it's good to go. So I do check the rotor a couple times, making sure that our dots are staying aligned. And then I went ahead and put the case back on here, and I thought we were good to go. However, as you guys know, a couple days later, I would look at the back of the watch and see just how far the dots were misaligned. So, as I was looking at that, I decided to go ahead and move the rotor around. And as you rotate the rotor around, you can already see that dot's starting to move. So we'll go ahead and really spin this a few rotations around just so you guys can get a good idea about how much that dot's moving. So go ahead and give it a few more rotations here. And yep, you can definitely see that, just how far that dot moved. I'll go ahead and pop in a still comparison here. So you can see in just 14 rotations that that dot has moved about 90 degrees. So I went ahead and ran an experiment. I, put both of these watches on. The Coke build does not have an aftermarket rotor, and the Batman GMT build does. So they're both NH34s, and one with an aftermarket rotor, one without. I put them on and wore them for the same amount of time. I did not wind them by the winding stem at all. They were both dead when I put them on wrist. I just wanted to test how efficient the rotors were winding. I even switched wrists midday because I'm right-handed, just to eliminate as many variables as possible. And the winner was the Coke build. So the Batman started running on the 14th at 12:07 p.m. and ended on the 15th at 3:46 p.m. And the Coke started running on the 5th at 12:07 p.m. and ended on the 7th at 3:30 a.m. So the Batman ran for 27 hours and 39 minutes, and the Coke build ran for 39 hours and 3 minutes. That works out to be a difference of about 11 hours and 24 minutes. So quite a substantial difference. And I do think this does prove that the OEM rotor is quite a bit better at winding the movement compared to an aftermarket one. This is by no means a perfect experiment. Ideally, I would have liked to have them both in a watch winder, set on the same setting, ran for the same amount of time, just to eliminate as many variables as possible. But I still think it serves as a good, indicator that the OEM rotor is better. The aftermarket rotor will still wind your movement, and if you're active enough, you might not notice a huge difference. However, I still wanted to double check and make sure that I didn't do anything wrong. So I grabbed a junk movement from one of my drawers. This is one I just keep around for learning purposes, and I decided to remove its rotor, see if I could put it on and have the dots aligned. So go ahead and remove it the same way we did before. One finger on the rotor to stop it from moving. Go ahead and unthread it from the crown. Grab it with a pair of tweezers. And then we're going to go ahead and reinstall it back onto the movement. Again, same way we did before. We're just going to go ahead and set it onto the movement. And then, make sure it's aligned with our crown tube. One finger on the rotor to make sure it doesn't move on us. And we're going to go ahead and thread that in. And like I said, this is a junk movement, so if you see me touching it with my bare fingers, don't worry. This movement doesn't run, hasn't ran for a long time. So we'll go ahead and thread that down, make sure it's nice and tight, and go ahead and test and see if our dots are in fact staying aligned. So, go ahead and give it, quite a few rotations here, because we know it takes a bit for even an aftermarket rotor to come unaligned. So I'm really rotating this thing around here, quite a few rotations. And as you can see, the dots are still staying aligned. So there are some options like these rotor stickers. They make use of your OEM rotor, but they kind of give you the look of an aftermarket rotor. So, you'll still get your winding efficiency. But if you're like me, my mind automatically went to pressing out the bearing from the OEM rotor and installing it onto the aftermarket rotor. So I've done dozens of bearings in my lifetime, more than I can count. Just in this one case of this one motor here, I probably did like 5 or 6 bearings, the crank, the counterbalance, both bearings for the transmission set. One's a needle bearing, but you get the point. Here's another bearing here that I just recently did on a water pump. So, you guys get the idea. However, I've never done a bearing this tiny. I mean, this thing is minuscule. Look at it on the tip of my tweezers there. But we'll go ahead and give this a shot. So what I did is I used my hand setting tool because I wanted something with a nylon tip that wouldn't scratch or damage the rotor bearing. However, you really ideally want something with a bigger diameter because you want to press on that outer race of the bearing. So this is a little small, and you really don't want to be pressing on the inner race when you're, installing or removing a bearing. Like I said, you want to press on that outer race. So, ideally I'd like to have something with a larger diameter, but that's all I had. So I went ahead and grabbed a 6mm socket. Now this is the perfect tool for this. Um, 6mm is the exact circumference of that circle there in the middle of the rotor. So it's going to work great as like a little bearing jig. So I'll go ahead and flip the rotor around so you guys can get a better picture of just how good this matches up with that diameter of that, inner portion of the rotor. And there you guys can see that it's perfect. It comes right to the outer edge. It's going to give us plenty of support on that rotor when we go to press out the bearing. And also that inner diameter is big enough to let us drop our bearing right down inside of it. So we'll go ahead and get this set up. And we'll go ahead and grab our hand setting tool here and, go ahead and press this bearing out. This does require a decent amount of force. I even have to use 2 hands here. But when you press it out, you'll hear a nice positive pop and we have our bearing out. So go ahead and dump that out. And mine's a little dirty because my socket's a little dirty because I use my sockets, and so it's a little oily inside there and stuff. So just give the bearing a little clean with, some air, a little bit of Rodico, and here it is. So now we removed our bearing, but I definitely want to reinstall this on the rotor and then double check our alignment dots. So we're going to reinstall this, same way that we, removed it, but in reverse order. So we'll go ahead and flip it over. The good part about reinstalling it is there's that little gear on the back there. So it'll prevent you from pushing the bearing too far in. So we'll go ahead and set it on our little socket here and support it on that outer diameter. And we'll go ahead and press it in. And when I press this in, I press in the center, but I also press on the outsides here. You can see I kind of go in a little crisscross pattern down on the left side now. Now I'm going to like the upper right side, and then I'm going back to the lower right side. So kind of want to go around that outer diameter of the bearing when you're pressing it in. But you can see here, we've got it pressed in. Rotor's a little dirty, so I'll go ahead and wipe it off real quick. And here it is. And now you can see that it's sitting flush with the rotor. And we're going to go ahead and test it with our screwdriver just to make sure that the bearing still feels good and that it's rotating, and it feels great. So we're going to go ahead and reinstall this back onto our movement here. So same way we did before, we're going to go ahead and install it with a pair of tweezers onto the movement. And we're going to make sure that it's aligned with our crown tube here. So we're going to go ahead and set it on and use one finger to hold it still. And we'll go ahead and thread that down with our homemade screwdriver. And go ahead and get that snug down. And now we can go ahead and check and make sure that our dots are aligning. So you can see that the dots are in fact aligning, but again, we want to give this thing quite a few rotations just to be on the safe side here. So I'm double checking, and then I'm really happy with how it looks so far. But let's go ahead and really rotate this thing around quite a few more times here. So now that we've done that, you can see our dots are still aligning. So I'm pretty happy with this, and I got some confidence now, and this is probably the way that I'm going to install my next aftermarket rotor. I'll press out the aftermarket bearing and reinstall an OEM bearing. But let me know down in the comment section, guys, are you guys just going to keep your factory OEM rotor? Are you more of like a sticker kind of person? Or are you just going to, say, screw the winding efficiency? As long as it does wind the mainspring, at some point it should get up to the full power reserve, and just rock your aftermarket rotor with an aftermarket bearing? Or are you more like me and you're going to go ahead and press it out and then press a new one in? I will let you guys know the next time that I do an aftermarket rotor, and I'll make sure to make a video on that. Anyway, guys, I hope you found it useful. Thanks for watching, and I'll see you in the next one.